Hello everyone, and I have another problem to solve in this video. We have this one. An object moves in a straight line with its movement as shown below. Determine the total traveled distance and the displacement of the object. So we have, let's try and solve this one solution. So we have the movement of the object as described in this figure. We have a velocity and a velocity axis and a time axis. So what we see here is that at time 0, the velocity is also 0 since the movement of the particle is defined by these slanting lines. Okay? And then at time 1, it has now a velocity of 10 meters per second. So notice that the velocity is not constant, therefore there is acceleration. So how do we determine its traveled distance or the distance it traveled during for this entire movement from time 0 to time 3 seconds? Now if you notice, if we multiply the width times the height, you actually get the shape or the area of this triangle here. Now why do we do that? Why do we consider that? If we notice, the width is actually time, that is in seconds, while the height is in velocity, meters per second. If we multiply meters per second with second, we get the m or the meters. That is actually now the distance. For problems such as this, we can use figures, the velocity and time axis, figures such as this, to obtain directly the distance. Simply obtaining the area of the enclosed part, or this area and this area. So from time 0 to 2, this area is the traveled distance. From time 2 to 3, this area is also the travel distance. So when we need the total travel distance, we simply need to solve the area of this rectangle plus the area of this other rectangle. So we now have the total traveled distance, area of the first rectangle, we have 1, the base is 0 to 2, so that is 2 seconds, by the way, 2 seconds, times the height is 10 meters per second. So notice, seconds times meter per second, you get a meter in unit. Plus the area of the second rectangle, we have 1/2. The base is 2 to 3 seconds, so we have a 1 second base, so 1, times a height of 10. Now we still don't consider the negative 10 since we are only concerned with the area. We add them up, so we have, this is now the total travel distance. We solve it. 1/2 times 2 times 10 plus 1/2 1 times 10. We get the answer of 15. So this is now 15 meters, the total travel distance, 15 meters. The next question now is the displacement of the object. Now, is the displacement of the object equal with the total travel distance? Now, let's try and inspect the movement. If you notice over here, at time 1 second, the velocity is positive 10 meters per second. While in the time 3 seconds, the velocity is negative 10 seconds. Now, note that the object is moving in a straight line, but the velocities are changing in value from positive to negative. Now, what does this mean? It means that from 0 to 2 seconds, the object is moving with a positive velocity, or the object is going to the positive direction. For time 2 to 3 seconds, the velocity is negative, meaning that the object is now moving to the negative direction. If we consider going to the right is the positive direction and going to the left is the negative direction, this is still a straight line, straight right and straight left. So we know that the object from 0 to 2 seconds, it is going to the right, while from 2 seconds to 3 seconds, for time 2 to time 3, that is now the object is now going to the left. So what the object did is it started from moving to the right, and then when the time arrived at t is equal to 2 seconds, the object now moved slightly to the left. So the displacement is now this part. That is your displacement. Okay? So how do we solve the displacement? Okay, let's say displacement or delta D displacement. Okay? To solve it, as I've said, this part is the travel distance for 0 to 2 seconds, while this part is now the travel distance for 2 to 3 seconds. We will now use their values, or their positive and negative values, since we are now interested with the displacement. We'll still have this one, 1/2 2 times 10 plus the area of the second triangle, 1/2 1 times 10. But now we will use their positive and negative values. The first triangle, 10 is positive. The second triangle, it is now negative. So we have a negative 10. So we now have the displacement is equal to 1/2 2 times 10 minus 1/2 plus 1/2 times 1 times negative 10. We have our answer is 5 meters. So our answer is positive 5 meters. Positive 5 meaning the displacement is going to the positive direction, or 5 meters going to the positive direction. Okay, so we have 5 meters.